Dear students, today we will discuss about the semiconductors family and different devices of the semiconductors. So there are different semiconductor devices in the semiconductors family. So there one is the diode and second one is the transistor and third one is the thyristor. So here diode is the basically two-terminal device, semiconductor device, and which is made by the P-type and N-type semiconductors. And transistor is also three layers or three-terminal device, and which is PNP and second is NPN type transistors. And third one is the thyristor or SCR, that is the silicon control rectifier, which is the also three-terminal semiconductor device. So thyristor is the most important type of power semiconductor device. So SCR is the power semiconductor devices. A thyristor is a four-layer semiconductor of PN structure with three PN junctions. It has three terminals. One is anode, second is cathode, and third one is gate. So we can say that thyristor is the four-layer, three-terminal semiconductor device. They are operated as bistable switches from non-conducting to conducting state. So this is the property of bistable device in which two stables, one is stable and second is non-stable. So this operates as a stable switch from non-conducting to conducting stage. This also called unilateral switch also. So this is the behave as a unilateral switch. The word thyristor is combined from the thyratron and transistor. It was invented in the year 57 at Bell Laboratories. So there are different semiconductor device which is in thyristor family. So one is SCR, second is Trike, third is Diode, and next one is GTO and SUS and also SBS. So these some device are the family of the thyristors. In thyristor or silicon control rectifiers SCR, so the symbol of the SCR is the have three terminal gate, anode and cathode, and also it have four layers, P layer, N layer, P layer, N layer, and three junction J1, J2, J3. So this is the symbol of the SCR or thyristors. There are some constructional features of the SCR. So in this constructional features, there generally two transistors are connected to each other. Here transistor Q1 and Q2, two transistor. That is one transistor is NPN and second is the PNP. The transistor Q1 connected to the base of the transistor Q2 by the emitter terminal, and transistor Q2 emitter connected to the base of transistor Q1. So this is the construction feature of the SCR. Now we draw the VI characteristics of the SCR, or graph between voltage versus current for the thyristor or SCR. So there is forward conduction region in this graph and also a reverse conduction region. In forward conduction region, there is the holding current IH and a forward blocking region. There is the off state, and there are different gate currents IG1, IG2, and IG0. And there is a forward break over voltage BFO, and the different gate currents IG2 is greater than IG1 and IG greater than to the IG0. So that is the forward conduction region in that SCR in on state. But in the reverse conduction region or reverse blocking region, so there is a reverse breakdown and also a reverse leakage current IR and a maximum reverse voltage VBR. That is the maximum reverse voltage. So in reverse region, there is a reverse breakdown occurs in this region. Or in this region, the current is not flow or flow in case of very small amount in the range of the nano ampere or microampere. So this graphical representation between the current versus voltage show the VI characteristics of the SCR. So in this graph of VI characteristic of SCR, we have a latching current IL. So what is the latching current IL? The minimum value of anode current is required to turn on a thyristor from its off state and a usually greater than the holding current. So this is the latching current. Next, we have a holding current in this graph. So what is the holding current IH? The minimum value of anode current required for a thyristor to maintain itself in conduction state. So this is the holding current. What is the forward blocking modes in the VI characteristics of SCR? So with anode to cathode voltage being small, only leakage current flow in that case through the device. The SCR is then said to be in the forward blocking states. And forward conduction mode, thyristor is brought from forward blocking mode to forward conduction mode by turning it on by exceeding the forward break over voltage or by applying a gate pulse between gate and cathode. So these are the two techniques to for turn on the thyristor. So in this forward conduction mode, we can also see in this diagram there is a different uh, junctions J1, J2 and J3, and there are a forward conducting state of the SCR, and next one is the reverse blocking mode. So in reverse blocking mode, the cathode is made positive with respect to anode with gate is open. Thyristor is reverse biased as shown in below figure. So in this figure, thyristor is a reverse bias. Here junction J1 and J3 are seen to be reverse bias, whereas junction J2 is forward bias. The device behaves as if two diodes are connected in series with reverse voltage applied across them. So this is the reverse blocking modes of the SCR. What is the effect on gate current on forward blocking voltage? So this graph shows the effects on gate current on forward blocking voltage. So there are different gate currents IG1, IG2 and IG3, and at the different voltage level. So at the voltage V3 gate current IG3 and the voltage V2 gate current IG2 and voltage V1 gate current IG1. So there are different gate current with respect to different voltage values. Next one, Thyristor triggering method or Thyristor turn on method. So there are different methods. With the help of these methods, we can turn on the Thyristor or SCI by the different techniques. So first method is the thermal turn on or high temperature triggering. Second one is the light triggering, and third one is the high voltage triggering method. And fourth one is the dV upon dt triggering method. And last one is the gate triggering methods. So there are total 5 types of triggering methods. With the help of these, we can turn on the thyristors from off state to on state. First one is thermal turn on or high temperature methods. In this method, the width of depletion layer of SCR decreases with increase in junction temperature. By increasing the junction temperature, the reverse bias junction collapse, thus the device start to conduct. This type of turn on may cause thermal runaway and is usually avoided. So this is the thermal turn or high temperature methods. Next one is the light triggering method. In this method for light triggering, SCR a special terminal is made inside the inner P layer instead of gate terminals. When light is allowed to strike this terminal, free charge carriers are generated, and when intensity of light becomes more than a normal value, the thyristor start conducting. This type of SCR are called as a laser SCR. So this is the light triggering methods. Next one is the high voltage triggering method. In this method, an additional forward voltage is applied between anode and cathode. When the anode terminal is positive with respect to cathode, so junction J1 and J3 is forward bias and junction J2 is reverse bias. So in that case, no current flow due to depletion region in J2 is reverse bias except leakage current. As BAK is further increased at a voltage VBO forward break over voltage, the junction J2 undergoes avalanche breakdown, and so a current flow and the device tend to turn on even when gate is also open. So in this type of turn on is destructive and should be avoided. So this method is not a very fruitful in this tailoring for turn on the SCR. So this type of turn is generally should be avoided. Next one triggering method is the dB upon dt. In this method, when the device is forward-wise, junction J1 and J3 are forward-wise and junction J2 in reverse-wise. So we can also this in this circuit diagram. The junction J2 behave as a capacitor due to the charge existing across the junctions. Next method is the gate triggering method, which is the most widely used in SCR triggering methods. In this method, apply a positive voltage between gate and cathode. Can turn on a forward bias thyristors. When a positive voltage is applied at the gate terminal, charge carriers are injected in the inner P layer, thereby reducing the depletion layer thickness. As the applied voltage increase, the carrier injection also increase. Therefore, the voltage at which forward breakover occurs decrease in that case. So these are the some methods of triggering for a SCR, and now we will discuss about the selection of a SCR. So we consider some parameters for selection of SCR. First one, anode cathode voltage. Second one is anode cathode current, and also consider gate current, turn on time, turn off time, package, holding current, and operational temperature. So these are some parameters for selection of SCR. And what is the application of the Thyristor or SCR? So SCR used in AC DC converter or convert AC to DC, and used in inverters also, and application also in high power switches devices. So these are the some application of the SCR or thyristor. Next semiconductor device family device is the Trike. So Trike from triode for alternating current. It is bidirectional device, or it is also three terminal device. One is gate, second one is the anode A1, and third is the anode A2. So this is the three terminal device or bidirectional device. This is the characteristics of Trike, which is also show the VI characteristics or graph between current versus voltage. So there are different parameters. There are also a holding current in the forward breakover voltage region and forward conducting region, and also a reverse breakover voltage in reverse regions, and there is also a break back voltage in forward conduction region. So this is the characteristics VI graph between the current versus voltage of the Trike semiconductor device. Next semiconductor family device is the dike. Dike is basically two terminal semiconductor device, and dike diode for alternating currents or AC currents, and this is also a bidirectional. device. So dike is a two-terminal device, bidirectional device, and for the alternating current diode device. So these are the VI characteristics or graph between current versus voltage of the dike device. So there are different regions in this graph. On state for positive half cycle and on state for negative half cycle also, and off state for negative half cycle and off state switches or break over voltage also there, and the current in the range of milliampere and voltage take the in voltage in volt. So in Trikes, an acronym for triode AC semiconductors. Trike is a acronym for triode AC semiconductor. Trike conduct both direction of AC current flow, have the same switching characteristics as SCR, equivalent to SCR connected in parallel back to back. So this is equivalent to 2 SCR which is connected in parallel back to back. So this we have as a trike. Trike are widely used to control application of power to various types of loads. So in trike there is also three terminal G gate MT1 and MT2. What is the construction of trike? So in trike construction, a four-layer NP-NP device in parallel with a PNP-N device and designed to respond to a getting current through a single gate, and also in trike construction not equally sensitive to the gate current flowing in opposite directions. So there are trike construction concepts here. And next one is what is the advantage and disadvantage of SCR and trikes. So first is what is the current rating. So in the trike, the current rating up to 25 amperes and current rating for the SCR up to 1400 amperes. So this is very high current rating for the silicon control rectifier or thyristors. And also what is the voltage rating? So voltage rating for the trike maximum rating is 500 volt. But voltage rating for the silicon control rectifier SCR is maximum rating is 2600 volt. So the current rating is 1400 amperes and voltage rating is 2600 amperes. Sorry, volts. So current rating and voltage rating is very high for the SCRs as compared to trike. And also what is the frequency range of these two devices? So frequency range, operating frequency range for the trike is the 50 to 500 hertz. That is the range for trike frequency. And second, the frequency range for the SCR, that is the up to 30,000 hertz. So this is the very high frequency range for the SCRs. Trikes have difficult switching power to inductive loads. Next, two directional or bidirectional trigger diode. So AC used in trike circuit because they have non-symmetrical triggering characteristics. Most frequently used triggering device is the dike or diode. So what is the construction of two-terminal dike device? So there is the three alternately doped layers, which is the P and P, and the doping concentration around both junction is equal. So there is two junction J1 and J2. So doping concentration is equal around the both junction, and leads are only attached to the outer layers. That is the outer layers in this diagram, P layer and both P layers, and package like a PN junction. So we can pack the dike as a PN junction diode. So this is the construction of dike. A dike has the same effect on current regardless of the direction of flow. So one junction is forward wise, the other is reverse wise in that dike, and perform as if it contained two PN junction diode connected in series back to back. We can see this in that diagrams as given below here. So dike are most commonly used in conjunction with trike to provide full wave control of AC signals. Useful for controlling Dike are useful for controlling dams, heaters, and also speed of small motor. So these are the useful in the lamps, heaters, and speed of control motors. And thyristor can be tested with commercial test equipment or an ohm meter. Now refer to the operator manual for proper setting and readings when using commercial test equipment. An ohm meter can detect the majority of defective thyristors, and it cannot detect marginal or voltage sensitive devices. So thyristor can be tested with commercial test equipment or an ohm meters. Yes. In summary, thyristor include SCR, trike, and dike. That is also thyristor families devices. And SCR control current in one direction by a positive signal gate. So thyristor or SCR is the unidirectional device in which current control by a positive signal gates and turn off by reducing the anode to cathode voltage to zero, and SCR can be turned off by reducing the anode to cathode voltage to zero, And SCR used to control current in both AC and DC circuit. So SCR control the current both type AC type and DC type circuits. So this is the symbol of thyristor here, with three terminals, anode, cathode, and gates. And also thyristor can handle up to 1400 amperes current. So this is very high amount of currents. And thyristor have the voltage rating up to 2600 volts. And thyristor can also handle frequency up to 30,000 hertz. So these are the some features of the thyristors. Next one is trike. So in trike, that is the Y directional triode thyristor. So in this trike, the current flow in both directions. And trike control current is either direction by either a positive or negative gate signals. And trike also can handle up to 25 amperes current and have the voltage rating up to 500 volts. And also trike handle frequency up to 400 hertz. So require the use of a dike because they have non-symmetrical triggering characteristics. So next device of thyristor family is the dike. So dike is mostly used as a triggering device for the trike. Testing is done using commercial transistor tester or ohmmeters. So in dike testing is done using commercial transistor tester or a ohmmeters. So these are some books for this topics. First one is Electronics Device and Circuits by Millman and Alkias. And second one is the Power Electronics by the P.S. Bhimla. There are some multi-choice questions, and these questions are very important and very interesting, and to clear the concept of this topic. So question first is an SCR silicon control rectifier has PN junction. So how many PN junctions present in the silicon control rectifier? So option A is 2 junction, option second 3 junction, option third is the 4 junction, and option fourth is none of the above. So in that question, correct option is the option second, because silicon control rectifier has the 3 PN junctions, that is J1, J2 and J3. So SCR is the 4-layer, 3-terminal and 3-junction device. So correct answer is option 2 here. In next question, And SCR is a solid state equivalent of silicon control rectifier is a solid state equivalent of triode, pentode, gas filled triode, tetrode. So correct option here is option third, gas filled triode. So SCR is a solid state equivalent of the gas filled triode. So here correct answer is option third. Next question, an SCR has semiconductors layers. So silicon control rectifier has the how many layers? Semiconductors layers. Option A 2 layers. Option second 3 layers. Option third 4 layers. Option fourth none of the above. So here correct option is 4 layers, because in silicon control rectifier there is total 4 semiconductor layers, which may be PN, PN, and also NP, NP. And SCR has and SCR behave as a switch. So here option first, SCR behave as a unidirectional. Option second as a bidirectional. Option third is a mechanical. Option fourth is none of the above. So here SCR behave as a unidirectional switch, because the flow of current in SCR is unidirectional. So silicon control rectifier or thyristor behave as a unidirectional switching device. And next question, an SCR is sometimes called and silicon control rectifier or thyristor is sometimes called trike, dike, unijunction transistor or thyristor. So another name of the silicon control rectifier is Thyristor. So Thyristor or SCR is the same. So sometimes SCR is also called as a Thyristor. So here correct option is for Thyristor. In next questions, an SCR is made of silicon control rectifier is made of germanium, silicon, carbon, none of the above. So here correct answer is silicon, because silicon and also germanium is the semiconductor materials, and both semiconductor materials generally used for the made of semiconductor device such as transistor, SCR and diodes. But due to the some specific property of the silicon, so SCR is made by the silicon semiconductor material, because silicon have some specific properties as compared to germanium silicon. So here correct answer is option second, silicon. So SCR is made of the silicon. In next question, in the normal operation of an SCR, in operation of the SCR, anode is with respect to cathode. So what is the potential of anode with respect to cathode in the normal operation condition of the silicon control rectifier or thyristor? So here option first is at zero potential. Option second is the negative potential, and option third is the positive potential, and option fourth is the none of the above. So here in SCR, we keep the anode as a positive with respect to cathode. So anode is the positive terminal and cathode is the negative terminal. So in SCR, anode behave as a positive potential at the anode terminal. So correct answer here is positive, option third. And silicon control rectifiers combines the features of. So what is the features in SCR combination, or what is the combined features of in SCR? So option first, a rectifier and resistance combined features. Second, a rectifier and resistor combined features. Third one is a rectifier and capacitor features. Fourth one is none of the above. So in SCR, the a rectifier and a transistor, basically the SCR made with the combination of the rectifier plus transistor. So this name is a thyristor or silicon control rectifier. So here correct option is second. SCR combines the features of rectifiers and as well as transistor. So SCR have the both device features. First features of rectifiers and second feature have the transistor features. So here correct option is the second. So they are the there are the some multi-choice questions. Thank you very much.